This video is sponsored by DataCamp, one of the best places to learn data science online if you're going self-taught, and also ranked #1 by Forbes for data science certifications. Get 25% off through the link down in my description below.
Alex, how are you doing? This is Alex Pasha. We went to university together, and we both studied data science. How are you doing?
Yeah, I'm doing good, thanks.
Yeah?
Yeah.
I'm looking forward to this conversation where we can talk about learning data science, the mistakes beginners make, all of that sort of a thing. So yeah, I'm really looking forward to it.
Yeah, me too.
So the first thing is, a lot of people, they're always wondering between going self-taught or going to university for data science. So obviously both of us went to university for it. I'm curious what you think about the whole university process. Is it worth going to uni for data science? The pros and cons? Yeah.
So actually, I did a mixture of both. I started self-teaching. My background is actually in the social sciences. And I started by teaching myself, kind of basic data analysis, simple machine learning stuff during COVID. I was stuck at home, just graduated, didn't really know what I was doing with my life. So I sort of started teaching myself all of these things because I thought they were quite interesting. I was like, this is the future. How do I find a role within it? So I started off on that route, and then, after about 5 or 6 months, I realized, actually, do you know what I could do with just, I've got some practical knowledge now. I've got some skills. I could go and build something, but I'm not quite there yet.
Yeah.
So actually, then applying to university, going and doing a master's in data science provided me the opportunity to kind of take the interest and the kind of practical knowledge that I'd already accrued and combine it with a more systematic mathematical knowledge, which was new to me, and then take both of those things into the workplace and create a whole new career for myself, essentially. Yeah. So I think there are benefits to both, really.
Yeah.
You certainly there is a definite privilege that comes with having a formal education in a subject like ours.
Yeah.
Because when you enter the workplace, you can be the person who kind of suggests the more systematic way of doing things, who can articulate maybe some of the more articulate solutions based more in the sort of mathematics or the conceptual underpinnings of a system rather than just the practical.
Yeah.
And people these days tend to think, oh, the practical is everything. But actually, I've obtained a great deal of kudos and value at work by being the guy who comes in and says, well, this might be the most obvious way to do it, but if you do it this way, for instance, if you apply even prior to data science, things like, proper database normalization.
Yeah.
Or, proper software engineering practices.
Yeah.
Good quality data structures. Finding the right data structure for the job in hand.
Yeah.
Then that means that you become the person who can actually push for better practices.
Yeah.
I work in financial services where you often encounter a lot of old systems. Some insurance companies are still using like COBOL mainframes.
Yeah.
so they haven't got rid of since the 1960s because they still have useful records on. So especially when you're in an industry like finance where there are a lot of older practices.
Yeah.
If you can come in and say, this is the correct way to do this stuff.
Yeah.
then actually that produces a bit of work for you, but it also produces a lot of value, which you can bring in as a junior.
And I think you gave the perfect example, because if you're going self-taught for something like database normalization, something that
Which is boring, by
It's
the way.
boring.
It's really boring.
and at a small scale, you don't have to do it. Like if you're just running a couple of queries, you could have everything in one NF, if that, and still run queries that get you the result that you need. So if you're self-taught, you won't see the value of digging into it. So I think going self-taught, there's that risk of
Cherry
having,
picking.
yes, and you aren't even doing it intentionally, but then you have like knowledge in certain areas, but then these gaping holes in foundational areas because you didn't have the need to learn that.
I think the value of university is, as you say, kind of you learn about the cutting edge, but you also learn about the really boring, unsexy stuff.
Yeah.
That nobody in their right mind is going to teach themselves. As you say, like proper database practices.
Yeah.
That is just boring. That module was awful.
Yeah. Yeah. That was rough. That was rough.
It was a rough module. It wasn't necessarily hard. It was just,
super boring. But I think we're both working in a sort of heavier data engineering space at the moment, and now it's starting to pay off for sure.
That's the thing. That module is actually the one that has probably helped my career the most.
Yeah.
And it's the least appealing module on the whole curriculum.
Yeah.
Because if you know, like, okay, picking up SQL is quite easy, but if you know what's going on behind the scenes and why SQL is the way it is, if you know kind of a little bit about database management, if you know a little bit about the mathematics of relations, then you can apply. You are much more likely to get things right first time.
Yeah.
And especially because I work in a sort of analytics environment, and getting things right quickly is kind of what determines whether or not the business thinks you're doing a good job.
Yeah.
So actually, the more quickly you can get to a good answer, the better.
Yeah.
And if you have a really systematic understanding of that kind of, how data is managed, even just, straightforward structured databases, like, okay, non-relational databases are kind of more interesting, but, if you can come into the workforce with a strong understanding of, like, how to build reusable, scalable data assets, even at a medium scale, then you're in just a much better place. And at the very least, you generate a lot of work as a data engineer.
Yeah.
Going through, if you work in, finance or in the public sector or something like that, where you get a lot of antiquated stuff.
Yeah.
You do sometimes end up untangling other people's spaghetti code, but hey, it's a job.
Yeah.
It needs doing sooner or later, and it produces, it produces a lot of value, because you just kind of scrape away all that technical debt and emancipate your team to actually do the interesting stuff.
Yeah. And I think on databases, one of the reasons I think I got my first job, my first internship, was obviously you get a take-home exercise, and it was like a spreadsheet, and they're like, oh, could you run some analysis on this? What value would you be able to generate from this data? And I did that, but then the additional thing I did to try and stand out was I was like, okay, first of all, I would never store data in this format because it was just like one big long table. So I actually drew them out a schema, taking it down to either 2NF or 3NF. And it's just like knowing those little extra things actually helps you stand out.
Yeah.
What are the disadvantages of going to university then? Because if we're saying the biggest advantages of going to university is you have that fundamental understanding and you have a little bit of privilege by a little bit of weight to your qualification. Are there any disadvantages to going to formal university rather than going self-taught?
money.
Yeah, yeah, that's the
The
biggest
obvious
one.
isn't it?
Yeah,
Because, you know, obviously it depends on where you're living and, you know, where you decide to go to university. But certainly here in the UK, like, there is some government support, but it doesn't cover
yeah.
much.
Hmm.
Masters tend to be a lot more dependent on your ability to fund some part of it.
Yeah,
So that is the main issue. The other one is like, yeah, it does take quite a lot of work. You know,
Yeah.
that was a pretty full on year and a bit.
oh yeah, yeah, 100%.
You know, we were doing like, I'd have like, at any given time I'd have like 3 assignments. Each one would require quite a bit of thought.
Yeah,
You know, it's a doable amount, but it is essentially you're kind of working full-time hours,
yeah,
not getting paid, because you're studying. So if formal education wasn't for you at a sixth form or,
yeah,
you know, undergraduate level, going and doing something like that is intense. But if you're really interested in it, if
Yeah.
you've got the passion for it, then obviously it's a good thing to do.
And I think the money element, I think that one's the most obvious one. But genuinely, what you've just mentioned about the time is you don't have the time to pursue any mini projects by yourself. For most people. So like, let's say you had all these assignments on like 3 at a time, like you said, and you wanted to go learn some new framework or some new library or some new piece of tech has just come out, and you're really interested in it. You probably don't have the time to pursue it to a good degree. You have to like put it on the back burner for a while.
Yeah, I had so many ideas throughout that year, and I was like, I can't do any of these currently.
Yeah,
Whereas now I work full time, but that is like 35 hours a week.
yeah,
And then it's like, well, there's still some time here and there that I can work on things.
yeah,
And definitely, if you can get yourself, the situation in which self-teaching makes sense is that if you can get yourself to a deliverable product, something that works, even if it's just, you know, a few open source contributions. If you make a meaningful contribution to a couple of open source projects, or if you know, create a somewhat decent Kaggle competition entry or something like that, that's when self-teaching really makes sense. And it's kind of a promotion through experience then to go and get a job.
yeah,
Whereas, but then when you get into that job, there is going to be, it is a trade-off, because then you get in there and actually there's all of this stuff that that the uni-educated people will know,
yeah,
that you won't know, and that will be a learning curve, and it's not really the same as like a business skills learning curve, where you could be learning, you know, you turn up in a job. One of the things I had to learn quickly for my job was Tableau,
yeah.
you know, which is just,
That one's decently easy to learn.
that was decently easy, whereas it's like, I have some colleagues who very much rose up through experience rather than formal education, and you know, they're very good at their job, but then sometimes it's like, actually there's a way that you could do this that would save you so much time.
Yeah,
And if you don't have a deep understanding of like the maths behind it, you won't pick that up.
yeah,
Like, you could be a really good software engineer, you could be a really good data engineer, but lack that kind of internalized, you know, you've like seriously in depth looked at some structure. And to be fair, sometimes, you know, in the uni setting, they skip through these quite quickly.
yeah,
But, you know, if you had to do some assignments on it or something like that, then there is a value in that.
yeah.
And I think that is kind of that's perhaps an unfashionable thing to say, because people like to think, oh, I can go and do things myself. And I think that there is definitely a strong case for that. But for a lot of people, I know certainly for me, I benefited from systematic aspect of it,
Yeah.
being subject to a kind of systematic program of learning, to then not only be able to do stuff, but also have the confidence to do it.
Yeah, I'd imagine the imposter syndrome of a self-taught person could get quite strong, especially when you do have those holes in your game and then maybe it's pointed out at work. Although these things you just plug through experience,
Yeah,
don't
you do. And I think either way, the challenges are surmountable.
Yeah,
That's the key takeaway.
yeah,
Here's the choice. If we were going to kind of narrow it down to a kind of binary, are you someone who can convert a sort of big-ish idea into something real?
yeah,
If so, teach yourself. If you are someone who maybe needs to figure out, you know, how they can actually build stuff, who needs that kind of, you know, structured thinking, go to college.
Is there anything that we didn't learn in university that you think should have been emphasized more? Or basically, if you could design your own data science university course, what like module that we didn't learn would you include?
I think a common deficiency in the teaching of data scientists and data professionals is just software engineering. You know, because the fact is, even if you're just going for data science positions, if you're going for a data science position at a prestigious company,
Yeah,
you're still going to get a bunch of data structures and algorithms questions at the interview, probably.
yeah,
So that's something that doesn't really get taught, and it's something that's kind of there were hints of it.
yeah.
We were having a chat before we came on about something that would involve like FIFO queues.
Oh, yeah,
and
don't remind me.
stacks and so on.
Yeah,
So those kind of like basic things do get picked up, but actually having, if there wasn't like, so the way it worked in ours was that the first term was very much, here are the foundations you need of maths, of software engineering, of databases and so on. And then the second term was AI.
yeah,
That was it. But actually, if in that second term, there maybe one of those AI modules had been replaced with just like advanced data structures,
yeah,
something that would teach you how to actually build applications in that really practical way, because that is the foundation that allows you to actually make good stuff.
yeah,
And that's something that's missing, and then you end up with a lot of data scientists who have no idea about application development.
yeah,
Well, they have some idea, but you know, often it's like they've never actually had to build anything with anything more complicated than, you know, a sort of a notebook with you know, and they do everything. We do everything in notebooks a lot of the time. So
shout out to Databricks, man. Enabling us to put notebooks into production.
exactly.
Yeah.
But you can't use Databricks for everything. So
Yeah.
actually knowing how to build out a more complex piece of software, I think would be really useful.
I think an easy win, something that's actually not that hard that we didn't learn, was modularization. That's the one. Because that's how you usually put things into prod, right? Like you have your Python script, then you modularize.
Modular? You mean like containers, like Dockers?
Not necessarily Dockers, but rather than having all your code in one big long script, breaking it down into chunks, import
separation of concern. Solid.
Yeah. Solid what?
Is that solid? You know, in software engineering.
There
this
we go.
is
why I should have learned software engineering.
This is why we should have had a bit more software engineering.
I just know it as modularization.
Yeah, so separation of concerns, modularization, those are good principles.
Yeah. Because I remember when I went to my internship, I had this really big piece of work that I've been working on for like 2 months. So I had this one giant Python script that was over 1,000 lines long. And then I took that to the software engineering department.
What did
And
your
they were
QA
like-
say? Did you have a QA?
The software department was the QA.
Yeah.
They were like, "What is this?" I was like, "This is my script. It does what it's supposed to do." And then they're like, "Go learn about modularization."
Oh.
And by the end, I think it was down to like the main script was like 30 lines, something like that. So
Yeah.
that's something that's really useful.
Well, because my dissertation project was quite software engineering, and something I picked up whilst researching that was like a general rule is like if a function starts going beyond about 30 lines,
Yeah.
in Python, which is a very concise language, maybe in C you can go a bit longer, then maybe you should think about breaking it down into smaller parts. Not always the case, and certainly if you look at a lot of important libraries and you dig into the code, and like you'll see like really long functions, but and functions within functions, but yeah, certainly breaking things down,
Yeah.
avoiding complexity, that is very important, isn't it?
If you were to restart, would you be going the self-taught route, or would you be going to university? Let's say you were thinking about going for the start of 2025.
I think I'm quite happy with the way I did it, where I started off by teaching myself the basics.
Yeah.
I did the cherry picking,
Yeah.
such that I knew enough that I could write a good personal statement and get into uni.
Yeah.
And then I then came into uni with a kind of a certain degree of conditioning,
Mm-hmm.
where I was kind of prepared for some of what I would be learning.
Yeah.
And I suppose that applies to anything, you want to take on a formal program of education on, is that, if you can do a bit of research beforehand, if you can maybe pick up some basic principles of what it is that you're going to be doing before
Yeah.
you go, then it makes the act of actually going and learning that stuff really intensively for a year,
Yeah.
or if you're at an undergraduate level for 3 years, a lot more manageable, because you kind of come into it with a conceptual framework already built, and then you're kind of then just filling in the gaps and like
Yeah.
expanding outward from there, and from a really strong starting point.
I'll be honest, I've come around. Before, if you'd asked me before, let's say the start of 2024, I would have said I definitely recommend you to go the formal route. But if I was to restart now, I would heavily lean into self-taught, because I think the speed of change of technologies and stuff, especially if you're going for an undergrad,
Oh yeah, for
3 years, like trying to anticipate what data science would look like 3 years from now.
if you're at an undergraduate level, just go and do a computer science course.
Yeah.
Yeah.
Well, I would still say go self-taught on that.
I think there are certain. Okay, in many situations, university is overpriced and undervalued.
Mm.
Overpriced and overvalued, rather. But I think with something that has a strong mathematical or empirical foundation,
Mm-hmm.
be that a STEM subject, be that economics, there is still value to having systematic, complete education on something.
Oh, undoubtedly. I don't think any of these career paths would be perfect. And I think it's good that we've landed on opposing sides. Not really opposing sides, but you get what I mean. That I think, because of the speed of change of technology, if you're a disciplined person, I would just go really hard at self-teaching for like a year, and then try and get an internship and fill in the gaps. Learn by working, essentially, is how I would do it. Because now I've also come across enough people in the real world, both as software engineers, as data scientists, and as data engineers, who went self-taught, and they know all the same stuff that I do. And obviously, because I've come across them, they're working in the same company that I do. So I think there's enough resources that if you can structure your learning and really be focused and dedicated, I would go self-taught.
Maybe, but then, it is a greater risk. You don't have the weight of a diploma on the wall.
Oh, 100%. I think that's why you'd have to go internship.
You would have to
or like
grind for a
lower
while
level
on
job.
internships and so on.
Yeah.
I mean, this is what I'm saying. You can make it work.
Mm-hmm.
But you kind of need both types of people in an organization of a sufficient size.
Yeah.
You're going to need both types of people. You're going to need people who are just very practical, very grounded, get on with it.
Yeah.
And you're going to need people who are a bit more conceptual.
Oh, 100%.
Someone who can come along and say, okay, well, how do we break this out into an application that is reusable and scalable, and that is the value of kind of proper formal education, I think.
So I'm curious, if I put it this way, let's say we have two separate timelines. Keep putting my foot up. Let's say we have two separate timelines. In 2028, we're going to be having two people who are applying for a job. Person A has gone to undergrad for data science. They've done their 3 years, right? And they've just come out. Person B went self-taught for a year or a year and a half. They went internship, did a bunch of learning on there. And then in 2028, both of those people are applying for a job.
Oh, internship person.
One guy has saved a bunch of money. He has practical work experience. Of course, I am sort of making it the ideal situation for that guy.
This is the thing. I would suggest that they're not necessarily going for the same job. So personally, I don't see the value in a 3-year data science, a bachelor's in data science. I mean, maybe there is virtue in it, but
I think we've spoken about this before, where we're like, our course was a 1-year master's, and we both found a lot of value from it. But we're like, if this was 3 years in an undergrad, what would we be learning for the other 2 years?
Yeah, I think it's a good augmentation to for someone who maybe a computer science person who's trying to specialize, which I know a lot of them are these days, because being a straight up software engineer, the job markets sound pretty brutal. Whereas data science is still quite a lot of growth. Even when the current sort of like stock market boom goes kaput, there's still going to be growth in enterprise data science. It's still something that's still, essentially a new profession that is still developing.
Actually, this is a great, sorry to interrupt, this is a great segue, but is there any things that you've changed your mind, or any misconceptions you had about data science that you've changed your mind on in the last couple of years, or in that transition from academic data science to working?
Just how primitive things can be. Sometimes, where it'll be like, oh yes, so this report is generated by data that we receive from a supplier. Okay, how do you receive the data from the supplier? Oh, they email us a spreadsheet every week. Okay, so then how do we ingest this? Oh, so and so takes the spreadsheet, checks that it's all right, and then manually uploads it to the server. Okay. And this is how we keep everything up to date. Yes. So you'll find particularly if you go and work for like a public sector, civil service or something, or if you go and work in large, medium to large companies that do kind of old-fashioned stuff. Yeah. You'll find these kinds of things, and that is probably the big shocker, is you spend time like learning. You know, whether you're self-taught or at uni, you'll be like, oh, this is what the cutting edge practices. This is how everything should be done. This is how everything is done. This is how the professionals do it. And then you turn up, and you see how the professionals do it, and they're not doing it that professionally.
Yep. There's a lot of that going on.
Yeah, there's a lot of that going on in
But
there.
people will be surprised how much value you can bring from just the most basic data skills, because you and me and everybody watching, we're all in the data bubble. So we think, oh, everybody is on the cutting edge as well. They already have all these systems in place.
They really don't.
Most companies don't. So I see a lot of people in the comment section, they're always worrying like, oh, data science is going extinct. Oh, the job market's saturated. No one needs a data scientist.
If you look at the stock market and you think, oh, we're having a .com crash, well, that wasn't the end of software engineers, was it? That wasn't the end of web developers. If you think about it, all the most important websites were developed after the .com crash.
Yeah.
You know, the kind of peak of software engineering as a kind of high value new profession, you know, the big dogs in town earning crazy money. When you look back at like what, you know, software engineer salaries were like 10 years ago, you know, the kind of peak of that was like late noughties, early 2010s, etc. I think we're in a similar sort of stage in the development of data science as a profession, where where the initial growth phase is happening at the capital level. Okay. Wall Street's eventually going to get bored of Nvidia and of all the kind of AI stuff, you know, and there will, you know, the stock market might crash, but actually the fact of the matter is that businesses, large and small, have realized that they need people to make sense of their data, and that is a demand that isn't going to go away. And so although there might be a peak and then a tail off as the hype around AI declines eventually, the need for data professionals is going to remain and be a long-term need. And in a way, I kind of think there is a sort of similarity between... I think in the long term, there will be a similarity between data professionals and things like accountants.
That's the exact example that I was thinking of, because everybody's obsessed with saying data science is saturated. Every data job is gone. How long have accountants been around? How many people are still getting qualified for accountancy? And I rarely hear anybody saying, oh, accountancy, there's too many accountants.
Well, the thing is that accountancy, from what I gather, they limit the number of graduates in a particular year. I obviously that would depend on place and time, but I think, we're kind of going through this kind of peak, but we're nowhere near that peak yet, to be honest, because there is so much more growth. And
most companies, they haven't even done the basic stuff. Like, we're obsessed with big tech companies and seeing all the fancy stuff they've done. Most companies don't have their data in a SQL database, for example, something that basic.
I mean, I had a meeting at work recently where myself and my manager were having to explain to our colleagues what Git's version control is. We had to like sit down for an hour and explain to them, this is how we quality assure code, and B, if someone makes a mistake, we say, oh, you broke this, can you go and fix it, please? And also, this is quite handy, if slightly underhand, if you work in an analytics capacity where being right is quite important, which is kind of toxic when you think about it. But anyway, if you can affirmatively say, oh yes, this is broken, sorry about that, the person who wrote this isn't here anymore. and you can say that definitively, then that deflects a lot of blame.
Yeah.
Do you know what I mean?
It's like a paper trail of saying,
Yeah.
I didn't break this.
Yeah.
Someone else did this.
Yeah, and then you go and fix it, and then you're the hero. It's great. Whereas
Go ahead.
Whereas before, like if everything's just, you know, like so much stuff, you know, especially in kind of medium to large companies, will just be stored, you know, on the Windows file system with no version control.
Excel.
Yeah, some of it in spreadsheets, some of it, you know, we had SQL code in like several different places, and it's like if something goes wrong with that, there's no accountability, so then the whole team just looks bad.
Yeah.
So actually, when you come in, you know, even if you come in, like, say you're self-taught and you've just made a couple of projects yourself, in some of these companies, you'll know more about version control than your colleagues.
Yeah. Well, on things that we didn't learn in university, we didn't have a single module on Git.
Yeah, but we had a lot of group projects. I think most of those were managed. Most people manage those with, well, I certainly managed mine.
We didn't.
Oh, didn't you?
No.
All the ones I did, I managed with Git.
I had to like self-teach Git. I knew there was this concept called Git, and then in the 2 weeks before I started working at my internship, I had to learn at least the basics of it. And, you know, I'm still polishing up on that as you know, on the project we've been working on. I got a little bit tangled and had to spend a weekend undoing my mess.
I think it is a rite of passage for anyone who works with software that you have to severely screw up a Git repository at some point.
100%. Because the thing is, it's such a behind the scenes benefit. If you get what I mean.
Yeah,
like,
it's very concealed.
you don't get credit. It's not visible to your stakeholders on your CV. It's a nice to have, but it's a vital.
It's so vital.
Yes. So because it's not right at the forefront, you're obsessed with maths, code. Have I built an application? Have I done this? This new technology is coming out. That is, you have to be disciplined to put aside time to learn. This is less sexy than database normalization.
Do you know what? Again, it's something that should be in that systematic formal education.
Yeah.
Much more so. Should be more forward.
Yeah.
I think in the software engineering teaching we did get, it was like maybe a week.
Mm-hmm.
But yeah, it really is important.
Yeah. I was going to circle back to something, but I've forgotten. I'm going to cut this part out. Oh, what was it? Because when you started talking about... Oh, I've forgotten. It's fine, I'll cut this out. Oh, I can't believe it. That was a great point. Hang on, let me check. You can make small talk. I'll cut this out. No, it's gone. It's gone. Anyway, hang on. I know I threw off the flow of this massively. This is going to be bugging me. It will come back to me anyway. Okay, cool. Moving on to the next thing. Are there any underrated, like, non-coding, non-mathematical, non-Git, non-database skills that you think are useful as a data scientist that could potentially help you to stand out?
Yes. The main one is communication. If you turn up to work and you have all the hard skills, all the technical skills, but you are unable to articulate what it is you are doing and why you are doing it, then you run into problems quite quickly.
Mm-hmm.
Your ability to kind of sell your work to the stakeholders, to communicate effectively with them, to create, useful specifications so that you can get it right quickly. The ability to do that is really grounded in communication. It's really grounded in your ability to take complex ideas and turn them into things that the business people or the creatives can understand, and B, to turn business needs into technical specifications.
Mm-hmm.
So it kind of goes both ways. So you have to, really learn, how to simplify and how to specify. Those are the two main ones. And also how to articulate the value of things, because particularly if you're working with non-technical stakeholders and you say, I need to go and do this, and they're like, why do you need to do that? This work. I had an example of this week where I was saying, I need to go and do this, and it was like, no, I don't see why you would need to do that because X, Y, and Z. And I was like, well, no, actually, to do what you think I need to do it this way. So actually, you then have to kind of take the time to explain to these people who might not know, the least bit about what it is you actually do.
Yeah.
Why you need to do things the way that you will. Also, how long it will take you to do each of those things.
Always say it will take you longer than it will actually take you.
Always slightly exaggerate it.
I always double it.
Yeah.
Yeah.
Well.
Then try to deliver way earlier. Then if I double it, if I say it will take 2 weeks, but I know it will take a week and I deliver it in a week, it looks more impressive, firstly, because they're like, you got this done so quickly. You're managing expectations, basically.
Yeah, managing expectations. You want...
We'll always be conservative with that, because especially if you're mainly working with non-technical people, first of all, they don't know how long something will take, so they're not going to be judging you.
Yes, and also, you tend to find that if people who work in non-technical fields and non-creative fields, so, the people who do straight up like business, for them, things have a much more stable lead time. Whereas if you do anything technical or anything creative, as we were saying, the lead time varies depending on things that you haven't even considered.
Yeah.
And just at a kind of psychological level, when you're working with people who are like, they work within a framework that says, if I put this much time in, this is the output that I will get.
Yeah.
Whereas for us, it could be that you get a really high output from a really small amount of effort.
Oh, yeah.
Or a really low output from a really high amount of effort.
Mm-hmm.
And that's dependent on knowledge. And that's why data scientists, software engineers, anything like that, that's why the pay scales go like that.
Yeah.
Why there's such a steep increase with experience, because the output that you can achieve is so dependent on knowledge.
Yeah.
In a way that is more extreme than for, conventional office workers.
It might be different for you because you work with a slightly bigger technical team, but one of the most useful skills that you can get is the ability to push back. First of all, not just on timelines, but being able to look your stakeholder in the eye, your boss who's, signing off on your paycheck and saying, I know you want us to do this, but I don't think it's worth it. I don't think the amount of time...
That is a big one.
Yeah. I don't think the amount of time and, changing things technically that it's going to take is going to result in any business value.
Yeah.
And being able to stand strong without getting fired, being able to push back. And that will also bring in the communication element.
Yeah.
Because you need to tell him why doing this little fix that's going to take 2 weeks isn't going to be worth it when we're thinking of the business problem.
Yeah. So that goes again into turning technical knowledge into business acumen.
Yeah.
And there was an example of this that I experienced about 3 or 4 months ago, where a request came in for a new report. So my work is kind of spread between data sciencey stuff and more traditional analytics. And there was a process that one of the kind of operational teams wanted automating. So we looked into it and we were like, well, how often do you do this process? I said, once a month. How long does it take you to do this process? Or about half an hour. Okay. So you want us to spend maybe 2 weeks developing a solution. It's going to save you half an hour a month.
Yeah.
That's not going to pay off for 2 years.
Mm-hmm.
Is that worth it? And then I said that to my boss, and he was like, yeah, okay, kill it.
Yeah.
And that is a good way to. So obviously, sometimes you will have to do lower value work
Mm-hmm.
because something just needs doing.
Yeah.
There might be, if you're a data engineer, there might be something that's just riven with technical debt, and you just need to go and refactor the code base. Okay, that's not bringing any new value. It's maybe preventing business risk from dodgy code, and also allowing you to develop better things in the future.
Yeah.
Okay, cool. Not everything you do is going to bring direct monetary value to the business in a way that's easy to articulate. But sometimes you will get given a request that's like, this literally isn't worth the effort.
Yeah.
And being able to kind of say, this is how much money you would make or save
Yeah.
from having this. This is how much money it's going to take you to employ me to make this.
Yeah.
This is the mismatch.
Is that worth it? Yeah.
Is it worth it?
Yeah.
And yeah, you're so right. Being able to say no,
Mm-hmm.
use that power sparingly.
Yeah.
Otherwise, you become known as the no guy.
Yeah. The guy who doesn't want to do anything.
Yeah. But yeah, say no when it is when it is clear that what they want you to do is just not worth it.
Yeah. And something else that's super interesting is, as you know, in our profession, how much self-learning do you do after work? How often are you having to pick up new skills?
At the moment, I work doing machine learning engineering for a medium-large insurance company. Long term, I'm really interested in the kind of the more like software engineering, production-y, actually making applications with data science, with machine learning, with AI. Now, I'm working on a couple of projects, one with yourself and one with another associate, both of which are kind of leaning towards that sort of area. And so as a result of those projects, I'm doing quite a lot of learning.
Yeah.
But I would say that at work, I have definitely, I've kind of learnt
The systems.
the systems, the things that they use.
Yeah.
And if I wasn't working on these other things, I would maybe be looking for some other challenge, either within the business or maybe looking for another job. But because for me at the moment, my focus is on, I go to work, I do my job, and then I'm working on these projects. And these projects are where I'm doing all the learning.
Yeah.
And these projects are where I'm learning the skills that will allow me to take my career where it wants to go. So you will find initially that there is a lot of work, a lot of learning when you enter the job. And then over time, that will decrease. But then you kind of have to be thinking about what the next step you want to take is, and maybe start learning for the job you want to have. Like you did when you were trying to either self-teach yourself or go to university.
Yeah.
Particularly for any computery job,
Yeah.
you have to kind of do that to advance.
And I think that's a natural transition in terms of you might not be learning off the job, but you begin to want to build stuff in your own time. Because something that's underestimated is how creative a job data science, coding, all of those sorts of technical careers are.
Yes.
Because I follow a lot of software engineers, data scientists on YouTube, and the evolution is almost always I'm learning these technical skills. Oh, I got my first job. Oh, I'm building my own startup. Because when you're in that space every day, you just get ideas popping off because there's so much you realize that you can potentially do. So whilst you might not be, I don't know, you might not be learning the skills, you then learn how to learn skills in context. So you might not be watching a 8-hour lecture on how RAG works. You're learning RAG through application and learning specific things.
Yeah, definitely. And you pick up so much just from like talking to people. I have a colleague, one of our sort of more senior data scientists, and we'll often just like, if both of us are having a quiet afternoon, he'll ring me up like, oh, Alex, can you look over this, these new features I've developed for such and such model? We'll start off talking about that, and then we will just have a chat about, like cool stuff that we've read, and things like that. And like, I don't know that he's working on any projects currently, but I don't think he's far off on having that like spark moment.
Big idea, yeah.
And we just have these chats whenever we're having a quiet afternoon at work, which, let's be honest, is quite often. Cut that out.
Maybe for you, Alex.
Yeah. But yeah, when and having that kind of environment of being surrounded by a technical team, you really do start to, if you're a person who desires that kind of creative, perhaps entrepreneurial side, then you will kind of find those people and you'll start talking to them, and that kind of spark kind of merge. So I definitely, I think once you start working, you are just immersed, aren't you? And that's what brings you to maybe coming up with the idea that might make you $1 million, or it might look very good on your CV.
Yeah, it's a win-win, basically.
It is a win-win, particularly early career. We were talking about this earlier as well, how once you're kind of 2 or 3 years in, you've maybe, like Nash has, gone through a couple of different roles, then the value of those kind of mini projects to your future career might start to tail off. But actually, if you have an idea and you start building on that idea, if you, with a little e, engage in that entrepreneurship, then that looks good on you, whatever stage you're at. That attitude, that self-startedness, that is a kind of a virtue that is appealing. The technical people are going to be like, oh, cool, you made this cool thing.
Yeah.
The non-technical people are going to be like, oh, this person's got get up and go. They've got, what's the word? Vim.
Chutzpah.
And they are sort of willing to kind of go above and beyond to build something.
And doing that as well, it will force you to start thinking from a business first perspective, because me and Alex were working on building our own thing, and this means that we have meetings all the time, and we're building the MVP at the moment. So we will have to go back and forth that, okay, this would be a cool feature. Is it good for the MVP? And we have to decide what we're going to include, how to allocate our time for the highest impact. Because though we're making $0 from this at the moment, we're like, okay, is it worth spending, 2 sprints on this feature that the end user will think is a nice to have. They might just use it a couple of times. And then we not only have to be able to communicate and sort of debate with each other and put forward why one of us might think this is worth it and the other one is not. We also have to be able to put ourselves in the user's shoes and see, okay, is this how much value is this providing versus the time put in?
Yeah, it's like if you're going into it, not all projects are entered into with the intention of creating a commercial product. But if you are going into a project and you think this might have commercial value, then it really does encourage you to start thinking very quickly about things with different hats on to what you're used to. So you'll be thinking product, you'll be thinking marketing, you'll be thinking finance, and creating that sort of broader, particularly, I think it's fair to say that both of us kind of tend towards being more generalists to an extent.
I'll circle back to this point after this.
Okay, maybe not. I would certainly see myself as more of a kind of generalist, and for me, it's like, well, actually, it's quite nice to kind of work with those different hats on and kind of think through each part of that. Like, okay, so what's the user experience going to look like? What's the, how do we finance this? What kind of operational costs are we going to have to consider, and so on and so forth? How does it scale? I mean, obviously, cloud is probably the answer to that, but it is quite fun. It's quite fun to just kind of try out those different hats, and you might realize that actually one of those hats is the thing that you want to do long term. So,
that makes sense. And maybe I should clarify in terms of general life, general business. Yes, I would agree that I do also tend towards generalist, but something that I've changed my mind on recently with data in general is that I used to be very much of the mindset of being a data generalist, not in terms of the skill, but in terms of the domain that you work in, just having sort of quote unquote generic data skills. I know how to build this thing, so I can go apply these skills in finance, in the medical sector, and all of that sort of a thing. But more and more, I'm beginning to tend towards it's worth picking a domain, and a domain that you like or you think you'll get value from, and tailoring your skill set towards what that domain finds valuable. And even your personal projects, this is particularly for people who are early on, I think it's worth it to tailor your skills towards the domain that you want to get into.
Oh yeah, definitely. So that is a good point. Deep domain knowledge.
Yes.
Deep domain knowledge. And that is even if you are a generalist, when you start working, in any capacity, you're going to have to develop an understanding of the business that you're working in, or if you're in the civil service of the department you're working in, and you're going to have to consider, you're going to have to pick that up quickly. And actually, when I started working, because I started working for an insurance company, I had to learn insurance basically. So I think it is possible to pick up a junior job or a graduate job with low domain experience.
Yeah. But the higher you go.
Yeah. But actually, a lot of the first year of that job is probably going to be you getting up to speed with that domain.
Yeah.
And that takes a lot of effort.
And it's not a great feeling having to ask somewhat basic domain questions that everyone else around you knows.
True.
For some people.
True.
I don't mind too much because I don't mind looking, not the smartest one in the room if I'm trying to learn.
Yeah.
But for some people, that would be a very not nice feeling.
Well, yeah, but so you you ask the questions you need to ask to get the job done,
Mm-hmm.
and you treat it like that. So you're not going to be the smartest person in the room on domain questions.
Yeah.
In fact, you're probably going to be the least smart person in the room on
Yeah.
domain questions. So you've just kind of got to eat humble pie
Yeah.
with that while you learn the domain, while you pick up. Actually, my manager was really good with this, where when I started, he set up calls with business leads in like 5 or 6 different units of the business to just explain their unit of the business to me.
Nice.
And like, if you can, obviously it depends on the culture in your company, but if you can maybe, ask to do some shadowing, or, I have some colleagues who actually, if you think in an insurance company, a lot of the interaction with the customers happens over the phone.
Yeah.
So actually, some of my colleagues, when they started, they went to the call center and worked in the call center for 2 weeks.
Well, they're doing sales.
No, like insurance claims.
Oh, okay, yeah.
So
yeah.
like, oh, so and so calls up, says, "I pranged my car. I'd like to make a claim, please," and they go through the process.
Yeah.
And then they would, kind of come back from that secondment with a bit of practical knowledge. So obviously that depends on the company that you're working with. They might not do that, but actually it's a strong case that you can put to whoever your first manager is, to say, hey, can I go and meet with some of the stakeholders, like one-to-one or in like a small group or something?
It's a
And
good
just
look as well.
Yeah, and just learn their business unit.
Yeah.
Can I go to, can I shadow some more of your meetings?
Yeah.
And just so that you sort of, it's like learning a language by immersion.
Yeah.
Because every domain that you go into is going to have a whole bunch of its own jargon, its own abbreviations, so many abbreviations.
Yeah.
And you're in effect going to have to build knowledge of a new language almost.
Yeah.
Or at the very least a new dialect.
Yeah.
So just the more that you can immerse yourself in that, then the quicker that you can learn
To immerse yourself in
Yeah.
the domain.
Mm.
I think that's one of the reasons why, well, coming up, I'll post this after, but yeah, I'm making a move back into the more sporty domain. I'm already halfway in it in my current job, but because I'm now realizing the advantages of specializing in a particular area, where I do realize if I'm applying to jobs within the sports domain, because obviously I studied sports science, so just the rate of getting responses back from companies or recruiters is not even 2x, not even 5x, but if I see the same job, one's in the sports domain, one's not, I'm probably at least 10 times more likely to get a callback in that domain.
That is a nice thing about data jobs, is the inherent interdisciplinarity.
Yeah.
So if, like us, you started off doing something else and then you come into data science,
Yeah.
then you always have a really strong option in going into that intersection.
Vertical, that domain.
Yeah.
It's similar to what you were saying earlier about software engineers, that if you're trying to sell just your software engineering skills at the moment, it's a tough ask. And I do think if you're trying to sell just your data science skills, you better be really, really good at just those skills. If you grew up in some bubble where you have, let's say, all you know is how to code and how to do math, if you're not great at those, it's going to be tough to just sell those.
Yeah. I suppose those people just go to the city and become quants.
Yeah. But again, you have to be at that high level to do that. You can't just be... Whereas if you have strong domain knowledge anywhere, it's not that you can be a bad data professional, but you
No.
don't have to be as high a level.
And also you can speak the language of the
Mhm.
people who are hiring you,
Yeah.
which is pretty handy.
Yeah.
They'll come at you with some technical industry terms. You'll be like, oh yes, I know about this.
Yeah.
I've worked with like I know enough about actuarial science
Yeah.
that if I went to work, if I went to apply for a job at another insurance company and they started asking me actuarial questions, I'd
Yeah.
at least be able to give maybe not expert but
Yeah.
informed answers.
I have the perfect example of this, and my job that I just got now, one of the reasons I think I got it is because I made a mistake in the interview. And this is because it's, sports data science, sports tech, it's quite a niche thing. So in the interview, I was like, oh, I would love to come work for, let's call it company A and company B. So I'm getting interviewed by company A. And then I was like, oh, yeah, the reason that I want to work for company B is that, oh, wait, no, sorry, this isn't company B. This is company A. The fact that I know those two niche companies within this niche domain, I think showed off that, oh, he knows this area. He knows this whole domain fairly well if he knows who the players are. So even by messing up, I was sort of showing my domain knowledge in a weird way.
It's the mistakes of an expert.
Yeah, exactly. Yeah.
Yeah.
Yeah. A weird question before we move into the AI talk is seeking mastery or striving for mastery in as a data professional versus coasting and being like, okay, I know these data skills, I'll pick up what I have to. Do you think it's worth going after mastery and trying to grind really hard to become really good at it? Or it's okay to just treat it as a normal job? Because I have some thoughts on this as well.
Depends on which aspects you're talking about.
So,
some things you're going to have to, really nail. You've got to. So, for instance, if you work with analytics, you've got to be really good at validating everything that you do.
Yeah.
Because if you say, "Oh, it's this," and then it turns out to be the opposite,
yeah.
you look like a mug.
Yeah.
So that's something, like that QA. That's very important. Seek mastery on that. Like, often now at work, people will get me to QA their stuff.
Yeah.
And yeah, it's kind of a long job. It's kind of boring, but it makes the whole team look better. If you work with, say, IoT,
Internet of Things.
Thank you. Then you're going to want to have a really strong understanding of how these sensors work and so on and so forth. So in each job, there's going to be things where you really got to get it right. And then there's other stuff where you've got to be good enough. And the skill in any job or any enterprise is figuring out what you need to get perfect and what you need to get 80%. Which things do you let the Pareto principle? Because actually, I used to have a boss who loved the Pareto principle, but to the extent that he would allow really fundamental things sometimes to slip.
Oh, it was just sort of like, 80-20, 80-20.
So long as everything's 80%, we're fine.
Yeah.
And then actually, there were some things that were 80% and they weren't fine.
Or there were 80% of the 80%.
Yeah, or they were 80% of the 80%, and then actually it turned around and backfired on it.
Yeah.
So actually, although on paper the team was producing a high output, because there were so many faults in the output, it reduced the prestige of the team and therefore, caused problems in the reliability and the trust in the reports that were produced, or the reliability and the trust in the machine learning models. And so, actually, well, if you think about it, it's easy for machine learning people to go, oh, everything can be 80%, because let's be real, if you've made a machine learning model according to proper best practices, it's
Yeah.
kind of hard for it to go above 80%.
Yeah.
Without it being overfit or something like that. But actually, the thing that you need to identify in any role is what things need to be spot on. Because it'll be a small number of things that need to be spot on. But you need to know what they are. You need to look for those. And that can be a bit daunting. It can be a bit scary. But if you just think through the job, talk to the senior people on your team, like ask them, like, what is the most important thing in this role? Because it'll be different in every role. As I say, in an analytics role, it's going to be reliability and trust. So you need to be reliable, you need to be trustworthy, you need diligence. If you work in a more kind of startup environment, building something that's more like creative, then maybe there's a bit more leeway there. So actually what you need to focus on is developing new features and making sure those features are really, they zing, they pop. And just finding, in any role, find the things that need to be spot on, and then let everything else be kind of like 80-90%, I think.
That makes sense. I would say, I guess we're approaching this from different angles in terms of, so you think mastery of the fundamentals, essentially.
Yeah. I mean, get your basics right, get your work really hard to do the things that stakeholders will notice.
Yeah.
If you're in a business, or if you are working in an entrepreneurial capacity, work really hard to do the things that your customers will notice.
Okay, that's perfect. So I think looking at, so you've taken the business or career approach. I'll take the more general approach, which is looking to achieve mastery as a data scientist / programmer, whatever, technical person. I think it's definitely worth it rather than coasting a lot and just being like, oh, I know the basics kind of well. I'll just, go to my 9 to 5. I think trying to get as good at these skills as you can without burning yourself out, blah, blah, blah. I think it's definitely worth it because, like you said, it's sort of like a hockey stick graph. Like, you get so many rewards for being near the top in terms of ability or efficacy or effectiveness, I should say, of being a technical person, if you get what I mean. So I think it's definitely worth putting in the time to get as good at these skills as you can.
And you should be trying to learn something. If your job isn't providing you enough learning opportunities and you're not quite in a position to get a new job, then find some time to learn. It's like, that something that a popular saying with kind of financial advice is pay yourself first.
Yeah.
The richest man in Babylon, all of that stuff, where it's like, whatever you're earning, you should try and save 10% of your net income. Maybe if you can kind of like map out all the free time you've got in a week, save 10% of that for learning.
Oh, that's a really good framework of thinking of it.
Like in the same way as you look at what you actually have in your bank account and you go, okay, I'm going to take 10% of that.
Yeah.
And put it away.
That's such a good framework.
Same thing with time, because again, time is the same. Is a similarly important resource as money. It's more important than money, and unlike money, you can't get more of it. So you actually have to kind of employ a slightly more zero-sum attitude to it.
Yeah.
So it's like, okay, I have this much free time. I'm going to give 10% of it to finding new skills, to developing myself as a professional, as a developer, as a creative, whatever it is.
Yeah.
That's a start, and then you can see where you can go from there.
Perfect. So I know earlier we're talking about specialization. One of the reasons why I'm getting bigger and bigger on specialization is because of AI. I feel, and I'm curious to hear your opinion on this, I feel like if you're just a data scientist with not much domain knowledge, AI is a bigger threat to you because all you're offering is your skills and not much beyond this. This is assuming you don't have elite level OpenAI skills. But I think as somebody with domain knowledge, you could then leverage your existing technical skill plus AI to achieve a supercharged effect.
So, to an extent, yes. However, I think that the nature of what data professionals do is actually sufficiently. It has an interesting mixture of objective and subjective. So, the objective is creating optimal models. The subjective is actually knowing which models to produce, how to, which targets to optimize for. Even things like which metrics to evaluate on, like, if you're doing a classification problem, like, do we want recall, precision, F1, mass use? There's all of these different things. And because there's so many, yes, it's technically an objective STEM profession, but so much of it is these kind of small decisions. I think it's quite hard. It will be quite hard for a large language, a generative AI-based system to create particularly automated solutions. So I think that for a good while, and this is why I made that parallel between data scientists and accountants, because I think certainly for the foreseeable future, the nature, accountants used to write things on spreadsheets by hand, and it took ages, right? So that might have meant that there were more accountants back in the day. And then since the 1980s, we've had digital spreadsheets, and these allowed accountants to have a lot more productivity. But that doesn't mean that there's no accountants anymore, right? And if the business, if the business environment that facilitates allows for greater productivity, then actually eventually the productivity gains balance out the labor requirements, and you still have a viable profession with lots of people working in it.
Yeah.
So I'm always a bit skeptical of this idea that AI is going to come and take your job, particularly as a data professional. Like an AI might be able to handle like some basic insights analytics.
Yeah.
It might be able to generate, might be able to sort of have a plain text, natural language prompt, and it will come back with a bunch of Power BI sheets. Right? That seems feasible to me. But actually creating viable enterprise machine learning models, I don't think generative AI is going to get there for a long time.
I see what you mean.
And also, like, just picking the data.
See, that's why I think we're actually thinking along a similar lines, because picking the data, knowing which features to optimize for, the deeper your domain knowledge, the more
better decisions you make. True.
Yes, which is why I think specializing. I'm not saying if you're not a specialized data science with a domain specialized data science, your job's going to be taken. No, that's not what I'm saying. But I'm saying the domain knowledge, it does insulate you a little bit more and allow you to be supercharged, if you get what I mean. Because if all you know how is, hey, if you give me a table, I know the words to type into Python to get my target, and then to get this number, I know generally to try and optimize this number, I try to, standardize and scale the features, that sort of a thing. You're still super valuable, but I feel like having domain knowledge of, these numbers are affected by these real world factors, which is why blah, 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 will put you in a better position.
It's good if you can have it, but I don't think it's currently necessary to have a career in the industry. I certainly not yet, and I don't. So yeah, I mean, we each come into data science with a secondary domain that we're kind of somewhat knowledgeable in. And that's great. But there are plenty of people out there who don't have that,
Yeah.
who are still having good careers.
Great careers.
Great
yeah.
careers. So actually, it's not. It's a great thing to have if you have it,
Yeah.
but it's not the be all and end all. So if you hear about this and you think there's an opportunity based on that for you, then it's great. That is a really great thing. It puts you in a really competitive position for finding a job. It puts you in a great position to think of maybe your own ideas.
Mm-hmm.
But if you don't have that, it's not the end of the world.
Oh, not at all.
You can still find, particularly if you do, like, so for instance, I came out of uni and I just kind of looked for a job
Yeah.
that was in data science. So this job comes up, machine learning engineer, insurance company. I don't know that much about insurance. I kind of know a bit about like coming from a politics background, I know a bit about law.
Yeah.
I know that there's some kind of relationship between insurance and law.
You can finesse it.
But I didn't actually, like they asked me questions about insurance in the interview. I didn't really know any of them. But then, like, all of the technical questions I aced.
Yeah.
And then it was just a matter of I got in there and just learn everything I needed to know.
So what I will say is that it also depends on the domain. Some domains are, we just want you to be really good at your technical skills and mathematical skills.
Mm.
I imagine insurance sounds like one of those. But the other thing is, imagine there was you who went through that exam, right? Not knowing that domain as much. Then there's a you, exact same level of technical skills, but who just loves insurance. He loves
Does
it.
anyone love insurance?
Hey,
I don't think
there's
anyone
people
loves
out there,
insurance.
but let's say
Okay,
they just
actuaries maybe.
they just had deep domain knowledge.
Yeah.
Is what I'm trying to say there.
Yeah.
I think the you with domain knowledge would have a leg up,
Yeah, he would have a leg up, but
it's not the be all.
it's not the be all and end all. And fundamentally, I got that job.
Yeah, because
And now we're working on stuff which is more in the direction I actually want to go in long term. But I think the reason why I say it's not the be all and end all is that you might find that for your first job, it will be in a domain that's something you just haven't touched before.
Yeah, first job's different for sure.
Yeah, like entry level, often like job roles like junior or graduate, the expectation of domain knowledge is much lower, and that's particularly true of finance.
Yeah,
definitely. But also, it could be, it'd be the same if you go and work for the civil service, because you might have some knowledge roughly of what the Department for Work and Pensions does. But, and it's not until you go and work there that you're really going to be knee deep in,
in the specifics.
Yeah, in how benefits work, for instance.
I should say it's domain knowledge, in my mind. It's not the cherry on top. It's the icing and the cherry. But there's still a cake underneath. So if you don't have your domain knowledge, you still have a cake. You said cake's great. But then
cake.
That domain knowledge is like the icing plus the cherry.
It's more important the higher up you go. So, I think.
Yeah, I'd agree.
If you want to move sideways, it's not so important. If you want to move up,
yeah, then it becomes more and more important.
Yeah.
So with AI in the mix, I have 2 questions for you.
Mm-hmm.
Go one at a time. If you're learning data science now, how would you leverage AI to learn more effectively?
Well, that's a good one.
Or would you? Do you think it's better to independently develop those core skills? Because, for example, for me, you met me in uni. My technical skills weren't great at all. If AI
they
was
improved very quickly.
Because they were so bad. It's not hard to go from 0 to 1. If AI was around back then and I could have lent on it, I would be in a much worse position now.
Really?
100%, because I feel like I would have lied to myself. Yes, I would have lied to myself, seen the output, and be like, oh, yeah, I knew that. Whereas when I had to submit that FIFO assignment, got 49%, that slapped reality into me. um, so how would you treat AI if you're first getting into data science?
Learn to distinguish the difference between things which are complex and things which are complicated. Now, what's the difference? If something is complex, it means that there are genuinely, deep systems involved and a conceptual framework that you need to develop and internalize in order to actually be capable and competent and articulate what needs to be done, versus things which are complicated, which are things that are not actually intellectually that deep.
Yeah.
But just have a lot of factors. So I would say, for instance, understanding how a neural network works, that is a complex system. So you need to internalize everything that you learn about that if you want to work with neural networks at a high level.
Yeah.
Whereas if you are just looking at, I don't know, how do I get this API to talk to this API?
Yeah.
That's not a particularly intellectually deep task. So you can just get ChatGPT to tell you how to do it. Because at the end of the day, you've not learnt that much in the long term from going through that manual process. So I think it's that distinguishing between those two different types of challenge.
I would push back even against that.
Really?
If somebody has no technical skills, I'm just learning, I don't think they would benefit from just saying, how do I do a call? Let's say they're learning. They aren't trying to just achieve a goal. I think they should try. This is how I would approach it. Try to do it by yourself. If you can't do it, ask for hints from an AI. Don't ask, hey, give me the exact line to do this. Sort of like prompted like, hey, I'm learning data science. I don't want you to give me the answer straight away. Teach me the concept so that I really understand. Because remember how we're talking about how you can have gaps, especially if you're going self-taught, some fundamental gaps. I think the more you lean on AI, depending on how you use it super early on, I think the bigger gaps you could potentially cover up.
That is a fair point. Yeah, and I suppose I'm kind of talking at this from the perspective of someone who is starting to do more learning again.
Yeah. The fundamentals.
But already, knows a couple of programming languages and how to use them.
I think once you know how to do it, where it's like, eventually I would figure this out. It might take me 45 minutes to figure this out, or I could just ask ChatGPT. But for sure you would have known how to achieve that. Ask away, man.
That's a good way of putting it.
Yeah, especially if you're at work or trying to achieve a goal. Yeah, I think that's ideal.
Yeah, if you're trying to build something and it's like, okay, I could probably figure this out in about 3 hours.
Yeah.
Or I could do it in 2 minutes.
And then you can revise the output.
Yeah, if there's something in the output that you're not sure about, go back and look at it.
How about in your working life or just your personal life? Still mainly data science focus. Any thoughts on AI and what it's changed?
I don't think we've actually really hit the major benefits of AI yet.
Is that because the project you and I are working on isn't out yet?
Oh yeah, because it's so revolutionary.
When ours comes out, that's when AI's peaked.
Well, aside from that, although that is very true, there is I think that the real value in AI is that it allows us, it's kind of a mirror, in kind of regurgitating the internet at us, which is effectively what it does. It kind of provides a mirror to your own thinking. And the value I see in AI, and I think the thing that will really provide the true value and help people improve their lives is when we can use AI to hold a mirror to ourselves, to think about, maybe the ways that we're approaching things. And I think when we have like voice assistants,
Yeah. Like
when
her.
or even like, do you remember TARS in Interstellar?
No.
Like,
But
anyway,
people
but yeah.
will. Yeah.
Or like, so like, I think once you have like a proper AI assistant that you can like ask little questions to, or do something like that, and if it could be set up so that it almost develops an ability to question your thoughts, or question you, and kind of make you stop and think, then I think that's really where the benefit's going to be, because it's going to lead to people that kind of pushing for a more intentional, more focused way of existence. That's very high level. That's my kind of hippy dippy side. But, I think genuinely that's where the value in AI is. It's how we can. It gives us a mirror through which to refract our thoughts.
Nice. I think that's a great statement to finish on. Really insightful. Giving me a lot to think about. But yeah, guys, that was Alex, one of my closest friends from university. Smart guy, as you can tell. I'm sure you guys will be seeing a lot more of him, especially with everything we're building. And I'm looking forward to having you back on, man.
Looking forward to it.
And don't forget to check out DataCam through the link below to get 25% off.